And here we are at 3.7, the end of chapter 3, with linear inequalities that have two variables. It means they've got an x and a y. This might sound a little weird, but it makes sense eventually. With our normal inequalities, we had a number line, right? Where this was 0. This could be 5, -5. And we would have a line that would point like this, right? And that meant all numbers greater than whatever this is. Let's say that's 4. All numbers greater than 4 satisfy this inequality. All numbers greater than or equal to 4 satisfy this inequality. You remember that? Where if it was an open circle, it meant greater than. If it was a colored in circle, it meant greater than or equal to. Okay, so this is similar, except that number line was just the x-axis by itself. There was no y-axis. Now, there is an x and a y-axis. And we're going to make a line, something like this, and to show the greater than or less than nature, you will shade in one side of that line. So this means all numbers on this side of this line satisfy an inequality. No numbers on that side. And any number on that line, because this is a solid line, any number on that line will also satisfy the inequality. As opposed to the other option, a dotted line. So this is, say, greater than or equal to, and this is just greater than, if we shade in the same area. That makes sense? So this is greater than or equal to, because it's all numbers moving to the right of the line, and this is just greater than because the line is dotted. So that means all the numbers to the right of the line, but not including any of the numbers on the line. Here's their first example. Y is less than 3x plus 1. So first we have to figure out what line it looks like. To do that, we're going to ignore the less than and just act like it's an equals for a second. Y equals 3x plus 1. That puts it in 3x plus 1. Messed myself up for a second. That puts it in slope-intercept form. So we know the slope and we know the intercept. So I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to go to y is plus 1 right here. We'll go up 1, 2, 3, and over 1. Go down 1, 2, 3, and over 1. Now I've got this line. Now I need to decide whether it's going to shade on this side of it or this side of it. I'm going to pick a point. I think because it's less than, it's going to be on the left side because it's pointing less than this way. I think. So that's what I'm going to try. -1, 0. I'm going to try the point -1, 0 and see if it works. Y is less than 3x plus 1. So then 0, right, because I took this 0 and put it over here, is less than, can you see that? Okay. 0 is less than 3x. 3 times -1 is -3. Plus 1 is -2. -2. 0 is not less than -2. I was wrong. It's this side. Because I picked this point and that made an incorrect statement, so it has to be the other side. And this should actually be a dotted line because it's just a regular less than. This one's a little hard to understand. I'll do one more. Graph this inequality. Oh, man, it's got a fraction. Okay, y is greater than or equal to negative 1/2 x plus 3. So I'm going to start by making myself this coordinate plane. And I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Start at plus 3. Negative 1/2. So I go down 1 over 2. Down 1 over 2. Now I've made this line. And I'm going to make it solid because it's a or equal to. The greater than or equal to. Now y is greater than. So I'm thinking y points up. So I'm going to say it's on this side of the line. That's my guess. Now I've got to check it. Let's see here. This is 0, 4. This point right here. So I'm going to check 0, 4. So 4 is greater than or equal to 3. 0 times half is 0, so just drop that 3 down. 4 is greater than 3, which is a true statement. 4 is greater than 3, which means I guessed correctly. And that is the thing. Okay.